Now pointer and array. So an array is a collection of homogeneous type of elements stored in adjacent memory locations. Therefore, it is used in the situation to store more than one value at a time in a single variable. So array and pointers have a close link. In fact, array in itself act like a pointer. जैसे हमने क्या किया? I'm just declaring an array int a, or suppose it is an array of 5 elements. Then the name of this array itself is a pointer, and it contains the address. Suppose जैसे हमारा one dimensional array हुआ ये. Okay, so suppose it is 0, 1, 2. These are the index values. 2, 3, 4, and suppose it is address 10, 20, 30. मैं normal way में ले रहा हूँ. I'm not just taking like this. I'm not just assuming it as integer, और integer की तरह assume करें, then it will be 10. It will be, suppose it is taking 2 bytes, so 12, 14, 16, and 18. So initially, the name of the array itself is a pointer, acts like a pointer, because it contains the address of the first element of the array. So if I'm just using this a, then the value of this a is 10. Okay, I'm just using the name of the array. So this can be used as a pointer to the array also. But in case of using pointers with arrays, the elements can be stored in arrays at different locations and can be called from the location when needed. And in this case, one more thing is this. So array and pointers have a close link. In fact, array in itself acts like a pointer, as one element in an array is stored adjacent to the previous. Array के केस में तो ऐसा होगा कि उनकी जो memory location है, it is contiguous in nature. So displaying the elements of array next to adjacent address is automatically called when its previous element is displayed. But in case of using pointers with arrays, the elements can be stored in arrays at different locations and can be called from the location when it is needed. So here are these 2 points that must be considered or remembered like this. We are having 2-3 minutes. So array elements are always stored in contiguous memory location. You know this. And the increment or decrement of pointers lead to increment or decrement of address based on the type of the pointer defined. ये अभी हमने previous कुछ example देखे थे, वहाँ किया था किस तरीके से हम pointers के addresses को वहाँ पे change कर रहे थे. So pointer along with single dimensional array can be used either to access a single element, or it can also be used to access the whole array. Like given a pointer only point to one particular type and not to all possible types. So when an array is declared, the compiler allocates a base address and sufficient amount of storage to contain all the elements of the array in contiguous memory location. So the locations in the case of array will be contiguous in nature. The base address is the location of the first element, index 0 of the array. The compiler also defines the array name as a constant pointer to the first element. जैसे मैंने बताया था थोड़ी देर पहले, the name of the pointer, the name of the array, okay, it is a constant pointer. And what is the mean of constant? Because its value will not change. It will always point to the first element of the array. So there will be a concept we will study after the completion of this topic, that is pointer. The topic name is linked list. So in that case, the linked list is a link of node, and there is a pointer which always point to the first node of the list, that is known as a start. But it is a constant pointer. It will always point to the first node of the list. Same like this, the name of the array is a constant pointer, and it will always point to the first element of the array. Okay, so an array is declared as follows, and assume the base address is 1000, so its base is 1000, and it is of integer type, and we are assuming 4 bytes are required for storing the integers in that system. So we are declaring an array here and as well as initializing the elements of the array. Array name is x. It is a constant pointer pointed to the first element x naught. So we are talking about the value of the x, then it will be 1000. So value of x is 1000, that is the base address, and the location of x0, that is x equal ampersand x0 equal 1000. It is like this. Okay, so this x will always point to this first element, or it contains the address of this. Okay, so it means like x equal ampersand x0. What is ampersand x0? Address location of this x0 element. X0 element is this, its address location is 1000, and this value will be there in the x. So the name of the array is a constant pointer which always point to the first location in the or starting location of starting address of the array, or the address of the starting element of the of that particular array. जैसे ये array है तो इसका first element ये हुआ, and it will contain the address of the first element. How? Let's see this example. So an integer pointer variable p can be made to point an array like this. Int x5 equal 1 2 3 4 5. Int star p is a pointer variable. P equal x. So look at carefully here. We are not writing, again I am telling you, p ampersand x. It is not right because it is the address of the first element. So p equal x, or we can write it like in this way, p equal ampersand x0. Okay, so this statement is invalid. Now we can use the successive array elements, can access them and can print them like this. How? Printf %d this star p, and we can increase the value of this p. Star p plus 1, star p plus 2, star p plus 3, like this. Okay, so star p plus 1, star p, we can say here it is p plus 1. P plus 1 means next memory location. If p contains 1000, then p plus 1 means 1 into 4, means it will be p plus 1 be 1004, like this. So we can write like this, star p, and increase the value of p, or we can also write it like this, star p plus I. We can increase this I starting from 0. Okay. Some more examples. So the relationship between p and x is can be shown below like this. P equal ampersand x0, p plus 1 is like ampersand x1, p plus 2 is like ampersand x2, p plus 3 like ampersand x3, ampersand x4, and so on. If the base address is 1000, then these will be the values for these different operations. So address of an element x is given by address of xi equal base address plus I into scale factor of int. So basically scale factor is the size of that particular variable. The size of this particular variable integer, if it is 32-bit system, then it will be 4. And we can access x0 equal 1000 plus 0, x1 equal 1000 plus 1 into 4, that is 1004, and so on. So this is a formula basically for calculating the address of each and every element at different locations. If we know the size of the data type of that particular array, then we can use this formula to find out the address locations of that particular array. Okay. Now, just a second. These are some examples. Okay, so address of x3 equal like this, 1000 plus 3 into 4, and so on. So array accessing using array name as pointer. It is same as like previous we have shown here, it is printf %d star p plus I, and we are increasing the value of I. It is a loop control variable. It means we have to apply a loop over there. So it is j equals 0, j less than 5, j plus plus star array. This is the address of the first element, means this. So for 0 it will be 0, for 1 it will be increased by that accordingly. Okay. If it is an integer, the address of, suppose it is 10, and the size of integer variable here 2 in this particular type, assume it is 2 byte, and it will be 12, 14, 16, 18. Okay, so array plus 0 equal 10, array plus 1 equal 12, it is 1 into 2, array plus 2 equal 14, array plus 3 equal 16, or array plus 4 equal 18, like this. Okay, and these are the locations, and we are using this dereference operator star 10, means value at this particular address 10. So that will be printed here. Now, array accessing using pointers, another example. This can also be done the same way previously. We are increasing it like this, or we can increase it like this, the same way, ptr plus plus ptr plus 1. So it will be like this, ptr equal ptr plus 1, then the value at that particular location. Now if you want to find out sum of all the elements stored in that particular array, then we can use the pointer for performing this operation. This is integer pointer, this is a temp variable, this can be a loop control variable, these are the array element, this is the array x5 name, 5 elements, name x. So p equal x. So basically p equal x means we are assigning in the p the address of this particular array. Now we can apply a loop here, as it will execute from 0 to 4, or we can say it will execute 5 times. So sum plus equal star p, loop control variable increased by 1, and memory location is increased by 1, p plus plus, and we are just adding every value at every memory location to this sum variable. So after this logical operation, the sum will contain the address of the element.